there are mainly two parts of elementary particles, right? One part is called fermions. Fermions. One side is fermions, other side is bosons. Take this down. You need to remember these words, right? Elementary particles can be divided into two parts. One part is fermions, other part is bosons. Fermions, bosons. Okay? Fermions further can be divided into leptons. Right? Leptons. I'll explain this as I'm continuing this. Then another one is lepton, another one is quarks. Leptons and quarks. Okay? There are leptons and then there are quarks. If you think about, there are 6 leptons, right? There are 6 leptons and there are 6 quarks as well. 6 types of quarks. These are the elementary particles, right? Elementary particles, take that down, elementary particles. Then there are 2 types of elementary particles. One is called fermions, other type is bosons. Then those fermions divided into leptons and quarks. We have to learn about 6 leptons and 6 quarks. Okay? 6 leptons and 6 quarks. Then these leptons, if you think about, they are single, right? You can find leptons as single particles. You know that electron is a lepton. It is just a one electron, right? You can observe that as a one electron. That is leptons. Quarks can be detected as 3 particles together or 2 particles together. Right? As 3 particles together or 2 particles together. If it is 3 particles together, then they are called baryons. These words you need to remember. For now, I'll explain this. Okay? Baryons. If there are 3 quarks together, then that is called a baryon. If there are 2 quarks together, then it is called a meson. Take it down. Right? First, you just have to remember this structure, right? Elementary particles can be divided into fermions and bosons. Then these fermions can be divided into leptons and quarks. There are 6 leptons, right? But these leptons can be found as single parts, right? Like one electron, like that. Then there are 6 quarks. There are 6 types of quarks. You can find them like 3 quarks together. If you find them as 3 quarks together, then it is called a baryon. If you found them as 2 quarks together, then it is called a meson. Meson. Okay? Right. I think you have taken this down. Okay? Now I am going to explain each of these. Right. Below this one, write down. First, I have to talk about leptons, right? Leptons. Write down leptons. Right. So we know that there are 6 types of leptons. Okay. Electron is one of the leptons. You are familiar with the electron, right? You are very familiar with the electron. Electron is a one type of lepton. Right? So first we have the electron. Then another type of lepton, we call that muon. Mu, this is mu, call it muon, right? Muon. Then we have tau. This is the symbol for tau. Electron, muon, tau. Electron, muon, tau. Okay. E you know. If you want, you can write this down. Muon means M-U-O-N. Tau means T-A-U, right? These are types of electrons actually. These are types of electrons. Then there are another 3 leptons. These are called neutrinos, not neutrons, right? Neutrinos. Tree, right? Not tro, tree. Neutrinos. It is written like this. This is called like simple V. Electron neutrino. Muon neutrino. Tau neutrino. Can you understand that? Electron neutrino, muon neutrino, tau neutrino. These are neutrons. Take it down. Now we have 6 leptons. 6 leptons. Okay. Then for these particles, these are single particles, right? There's only one particle here. For this one, it has charge of an electron, right? So let's say this is a charge, right? I'll say -1. This is relative charge, okay? This is charge. Charge of these particles is -1. All these particles, electron, muon and tau, has -1 particle. This is not -1 coulomb, okay? This is -1 charge of an electron, okay? All these particles have the same charge as the electron. So what is the difference between these 3? As you go to this side, what happens is mass of the electron is the smallest. Then these are like mass are higher, right? Higher and higher. Also is a size. So it is denoted by like this, right? Okay. Compared to these, neutrinos are very small, right? But as it goes to this side, compared to these, it gets larger. Okay. And these neutrons are actually neutral. Neutrinos are neutral. Neutral means 0 charge. Okay. Charge is 0. I think you understand that. If it is confusing, tell me. So at the first branch, we had leptons. There are 6 leptons, right? Actually, these are types of electrons. This is the electron, this is muon, tau. They have the same charge, but the mass is getting higher, right? As it goes to this side. And actually, these can be generated inside particle accelerators, right? These are not that stable, right? These quickly decays into the electron, right? Okay? These are not very stable, unlike the electron, right? Then these are the types of electrons. Then we have neutrinos. There are 3 types of neutrinos. Neutrinos are named like electron neutrino, muon neutrino, tau neutrino. So you need to remember this categorization, right? Understand? So that is all we need to know about. Leptons. Leptons is done, right? In the previous diagram, leptons is done. That is all you need to know. Right. Then you need to know about quarks. Write the topic quarks. So I told you that there are 6 types of quarks, right? 6 types of quarks. So we are going to draw a similar table. Mainly, there's a one quark called up quark, then there's down quark. Up quark, down quark. Then we have charm quark, strange quark. Then we have top quark, bottom quark. Okay. So these quarks makes up actually the neutrons and protons. You will see that later, right? For now, just understand this. The thing about quarks is this row has this much of a charge, 2 over 3, as the electron, right? 2 over 3. Up, charm and top quarks has 2 over 3 amount of charge. This down, strange and bottom, these quarks has minus 1 over 3. So these are relative charges, right? These has plus 2 over 3 charge. These has minus 1 over 3 charge. Actually, here as well, as it goes to this side, their mass is getting higher. To this side, their mass. To this side, mass is getting higher, right? And also they are unstable. To this side, it is getting more unstable. They quickly decays into up quarks and down quarks. They quickly decays into up and down quarks, right? Okay, take it down. Right. So we talked all about leptons, right? We have to further, because leptons, that is everything you need to know about leptons. They are single particles, right? They don't make other types of combinations. So this is all you need to know about leptons. But when you talk about quarks, I told you that quarks can make other types of particles. Quarks can make other types of particles, right? So we further have to discuss them. Then, what did we talk about quarks? There are 2 types of particles that a quark can make, right? Quark can make, one type is called baryons. Baryons, right? Another type of quarks, not quarks, right? The type that makes using the quarks. Another type is called mesons. So quarks produce quarks like by joining a few quarks, I mean 2 quarks, you can produce mesons. By joining 3 quarks, you can produce baryons. To make a baryon, you need 3 quarks. To make a meson, you need 2 quarks. Okay? Right. So, they have identified that, you know the proton, right? Proton is actually a baryon. Neutron also is a baryon. So if you think about proton, you know relative charge of a proton is +1, right? Proton is +1. Quark constituent of a proton is UUD. UUD means 2 up quarks and a down quark. A proton is made of 2 up quarks and a down quark. So let's see whether this charge of these adds up to become a proton. What's the charge of a up quark? What's the charge of a up quark? Huh? Up quark? So this is a proton, right? This is a proton. Up, up, down. Proton has what? Check from the table, you got 2 over 3, right? Then this subquark, also has 2 over 3. Down quark minus 1 over 3. Check the table. 2 over 3, 2 over 3. Then down quark has 1 minus 1 over 3. What do you get? 2 plus 2, 4 minus 1, 3. So you have plus 1. So this is how the charge of a proton, right, not photon, proton is made. You know the charge of a proton is plus 1, right? So when you add all these up, down, you get a plus 1. Then another type of common baryon is neutron. So what could be the constituent, quark constituent of a neutron? Actually it has, you know, the charge of a neutron is 0. Okay, so the charge of each of these should be added up to the 0. So up, down, down, up, down, down. Up means plus 2 over 3. Down means minus 1 over 3. Again down, 1 over 3. What do we get? 0, right? Understood. Don't write it at Mesons side. This is at the baryon side, right? So the first thing you need to understand is baryons are made of 3 quarks. 2 most common baryons are proton and neutron. Those proton and neutron are called baryons. So the proton is made of 2 up quarks and down quark. Neutron is made of an up quark and 2 down quarks. So you can see they must add up to their relative charges, okay, when you add them. Got it? Okay, you can take it down. And if you have a problem, ask me, okay? Send me a message. So this is written at the baryon side, right? Not meson side. I need to write here as well. So you are familiar with the proton and the neutron, right? So this is how the protons and neutrons are made. Okay, you can further divide those into these quarks. Right. Then you have mesons. Another type of thing that makes out of quarks is mesons. So to create a meson, you need 2 quarks. Okay, 2 quarks. Actually, there are 2 types of mesons. So actually these particles are made, you might not have heard this yet, right? But these particles are really common around us, okay? Actually these mesons are created like when cosmic rays are incident on the atmosphere for a short amount of time, these mesons are created, okay? Then there are mainly 2 types of mesons you need to know. One is called pions, right? Pions. Another one is kaons. Pions and kaons. Pions and kaons. And there are 3 types of pions. This is a symbol pi naught, right? Another one is pi plus. Another one is pi minus. Okay? So let's see how to form this pi naught. So you need to have 2 quarks to make this particle, pi naught particle, right? So what's the requirement? The final charge has to be 0. So what if we have up quark and anti-up quark? I didn't tell you about there are antiparticles as well, right? When we are thinking about pions, we have to discuss about antiparticles. Antimatter particles, you may have heard that. So all these particles have an antimatter particle as well. Only difference is they are identical to their matter particle, right? Let's say down quark. So you have an antimatter down quark as well, anti-down quark. Only difference is they have the opposite charge. So you know down quark has a -1/3, -1/3. So the anti-down quark has +1/3, right? Has +1/3. So if you add up quark and anti-up quark, so this has what? +2/3. Anti-up quark has -2/3. So when you cancel this, it becomes 0. So charge is saved there, right? Okay, charge is saved. Then, in order to make a pion plus, you can have up quark and an anti-down quark. So down quark has a -1/3. Anti-down quark has +1/3. Charge, right? Mainly we are talking about charge, electric charge here. There are many properties, but mainly we are talking about electric charge. So anti-down quark has +1/3. Then up quark has +2/3. Anti-down quark has +1/3. So when you add that, it becomes 1. So the charge is gained, right? Then if you think about pion minus, you can have anti-up quark and a down quark. Up quark has a +2/3. Anti-up quark has -2/3. Opposite charge. Always anti has opposite charge, right? So up quark 2/3, anti-up quark -2/3, and the down quark has what? It is -1/3. So what do you get? -3/3, -1. We got the charge, right? So you can see these pions are made of up and down quarks, and they can have matter and an antimatter particle. So antimatter particles, all you have to remember is they are identical to their matter particle, right? Antimatter. Only difference is they have the opposite charge. That's the only difference. Okay, right. Then we have kaons. Kaons. Thing about kaons is there must be a strange quark with that. Remember the strange quark? Look at the table, right? Quark table. There are 6 quarks. From that table, you need to have one of the quark has to be a strange quark. So let's say you need to make K plus, right? If you need to make K plus, you can have up quark and an anti-strange quark. So up quark has what? +2/3. Strange quark. What's the charge of a strange quark? Look at the table. Strange quark. It has the same charge as down quark, right? It has the same charge as down quark. So it is for the strange quark has -1/3. So anti-strange quark has +1/3. So you can see +2/3 and +1/3. You get what? 3/3. That is 1. In order to make kaons, one of the quark should be a strange quark. Can be anti or just a normal, right? So it is kaons. So let's make one more of that. Let's say K minus. So what's the requirement? One should be a strange quark, another should be a up quark. So if we have an anti-up quark and a strange quark, up quark has +2/3 charge. Anti-up quark has -2/3. Strange quark has -1/3. So it is added up to a -1. So you can create these kaons. Okay, right. Take it down. Just for now, just take what is on the board. After this, I'll give you a note on this, right? PDF. first just understand this categorization for now, right? Just take a rough note. If you are done, thumbs up. Thumbs up, right, if you're done. Right. Right. Okay. First, take this down. Write this down below this one, right? All the above particles, quickly take it down. All the above particles have their antimatter particle. All the above particles have their antimatter particle. All the above particles have their antimatter particles. I'll explain this again, right? Whole thing. All the above particles have their antimatter particles. Right? Those particles, write down to the same line, those particles are identical, but charge is opposite. Are identical, but charge is opposite. Right? Charge is opposite. This is antimatter, right? Write down examples, right? So if you take an electron, okay? If you take an electron, how do you write anti-electron? I mean, you write a dash above the electron, right? It is not negative sign you usually write, it is a dash above electron, right? So what do we call this? Anti-electron. What is the requirement? Everything is same as the electron, but what is the only difference? Charge is opposite. So you know electron has a negative charge. Actual value is this one, right? For the electron, okay? This value is what we call a 1e or a 1 plus, so 1 minus 1. This is minus this amount of in coulombs. That is the charge of an electron. If we take a anti-electron, only difference is its charge is plus. We have a special name for that. You might have heard this. It is called positron, right? I'm only using relative charges. You understand what relative charges means, right? Right. So this is anti-electron, and there's a special name for that called positron. So antimatter particle of electron is what we call positron. Then if you think about, we can have anti-up quark for the up quark. We have anti-up quark, then anti-down quark. Okay. Then we can have, like, if you have a hydrogen atom, you can have a hydrogen anti-hydrogen. Let's say, you know, hydrogen atom has a proton, right? Just a one proton, and there's an electron around it. Okay. What's the antimatter part? Anti-hydrogen means anti-proton, then anti-electron means positron. For the anti-hydrogen atom has a positron moving around it. Okay, so everything is not everything, I mean only the charge is opposite. Okay, so actually this is like a proton with a negative charge. Okay, so the thing is, let's say, did you take this down? Take it down, right? You can have a rough note, then I'll post a clear note on the group, right? So you have the hydrogen, and this is anti-hydrogen. Anti-up quarks, anti-down quarks. Anti-electron means positron. It has a special name, positron. Done, right? Thumbs up. Right. So now you are somewhat familiar with this. Okay. I'll again revise this. Okay. So we had elementary particles. Okay. Elementary particles. So what are the two types of elementary particles? You can check the note. Two types. One is fermions. Other type is bosons. I didn't talk about bosons yet, okay? I didn't talk about bosons yet. One is fermions, other is bosons. I didn't talk about bosons. All these are under fermions, okay? All these I discussed under fermions. Right. So then I talk about, there are two types of fermions. One is called quarks. One of the fermions is made of quarks. Other one is leptons. Check the note. Then there are 6 leptons. Those leptons are actually single, right? They are not together with other stuff. All those leptons are single leptons, right? Under that, you understood that there at the first row you have 3 types of electrons. 3 types of electrons. Their relative charge is 1, right? Their relative charge is 1. Then below that you have neutrinos. Neutrinos, okay? Neutrinos. 3 types of neutrinos. You have electron neutrino, muon neutrino, and tau neutrino. Okay? They are all charge of neutrinos is 0. They are always they're actually really small particles, even smaller than electrons, okay? And their charge also is 0 for the neutrinos. And when you go to this side, their stability goes down, they quickly decays, right, as you go to this side, and their mass is getting larger, mass is getting higher. Okay, so that is all you need to know about, leptons. Understand? All you need to know about leptons. Then there are other types of particles called quarks, right? We need to talk about quarks. So when we are talking about quarks, quarks are not single. You cannot have a up quark. You cannot see a up quark. You cannot detect a up quark, single up quark like this. Up quark is either with one more quark as two together or three together. Quarks always, right? So when there are three together, when there are three quarks together, we call them baryons. When there are two quarks together, we call them mesons. Okay, we call them mesons, right? Then for the neutron and proton, they are baryons, right? Because there are three quarks. Proton has two up quarks and a down quark. Neutron has up quark and a two down quarks. So you can add the charge of each quark, and those charges should be added up to the charge of a proton or a charge of a neutron. Okay, right. Then I talked about mesons. If we talk about mesons, there are many other mesons as well, but in the syllabus, one meson type is pion. Another type is kaons. Pion means there are three types of pions: pi naught, pi plus, pi minus. Then there are three types of kaons as well: k naught, k plus, k minus. Minus means the charges of quarks should be added up to this charge, right? Thing about kaons is one of the quarks should be a strange quark. For the pions, those quarks are either up or down. So in order to make these mesons, you must have those antimatter particles, okay? Antiquarks. You need antiquarks. So this pion. So what is the requirement? You need two quarks. To make this pion, you need two quarks. Final charge should be zero. Final charge should be zero. So how can we make that? Let's say up quark and an anti-up quark, or a down quark and an anti-down quark. So when you add the charges of these, it becomes zero. To make a pi plus, you need up quark, so 2/3 plus 2/3, and a down quark. Do we get plus 1? No, anti-down quark, right? You will anti-down quark, like that. You understand that? So similarly, you need to take pi minus. If it is a kaon, right, let's say k plus, one of the charge should be a strange quark, another should be, for the strange quark, it is minus 1/3, right? We need to make it a plus 1. So you can take anti-strange and just add a up quark. You get plus 1. Got it? So similarly, you can form these charges, right? So the main thing is those charges should match, right? Those charges should match. So in the exam, they ask questions like that. What's the composition of a pion? Right? What's the composition of a muon? What is a muon? Is it a lepton? Is it a baryon? Like that. That's the types of questions they ask. It's simple questions, right? Right. Below the note you have taken, just take this down. I don't know, did you write that when matter and antimatter particles collide, they annihilate or something? You didn't, right? No, right? Okay, below that, right? When when matter and antimatter particles, when matter and antimatter particles collide, they completely annihilate into energy. They completely annihilate into energy. So let's say example, if you have an electron and a positron, if you have an electron and a positron, matter and antimatter, right? Same type, matter and the antimatter particle. This creates two photons. You know photons means what? What do you mean by photons? Completely energy, right? Photons are energy. We take the actual two gamma means those are gamma photons. Done? Right. Then we need to talk about okay. Then we need to talk about forces. Write down forces. Forces. So you know many forces, right? You know many forces like normal reaction force, friction, all those. But those are not fundamental forces, right? So if you think about like normal reaction force, how does it create? That is created because of the like actually electromagnetic forces between atoms, right? That's why the surface gets hard. Okay. Actually, it is because of electromagnetic forces, those forces. Okay. So those normal reaction, friction, those are not the fundamental forces. There are four fundamental forces. One is electromagnetic force. Write down first one, electromagnetic force. Second one, something called strong nuclear, strong nuclear force. Third one, strong nuclear, then you have weak nuclear force. Third one, you have weak nuclear force. Then fourth force is gravity. Electromagnetic force, strong nuclear force, weak nuclear force, then you have gravity. Right? You need to remember this: electromagnetic force, strong nuclear force, weak nuclear force, then you have gravity. Those are the four fundamental forces. At the previous part, under fermions, we talked about particles, right? Here we are talking about forces. Forces are also due to particles. Right. So in front of this electromagnetic force, right? In order to create electromagnetic force under particle physics, you learn that you need to exchange photons. Photons means just, you know, the photons, not protons, right? Photons. You need to exchange photons. That is how they say that. You don't need to know how that happens or those stuff, right? You just need to know that electromagnetic force is caused due to exchange of photons. So when you have two charges, let's say 1 coulomb here, 1 coulomb here, you know that there's a repulsive force between those. In particle physics, we say that repulsive force is due to exchanging photons. That is how they explain that, right? You don't need in-depth understanding of that. Just know that these charges exchange photons, a particle called photons, between those charges. So the particle responsible for the electromagnetic force is photon, F-O-H-O-N-T, right? Then we have strong nuclear force. So that's a new force. Where do we have strong nuclear force? You know that protons and protons, they are actually like charges, right? They must repel. But these strong nuclear forces keep them together, right? Then there are, quarks inside the proton. Those quarks also is kept them together by the strong nuclear force. By the strong nuclear force. In order to cause a strong nuclear force, we have a particle called gluon, right? Gluon. Particle is gluon. Just know the name, that's enough, okay? In order to keep a strong nuclear force, it is done by exchanging a particle called gluon between the quarks and between the protons, like that, right? Gluon. Then we have weak nuclear force. To cause weak nuclear force, we have these are called bosons, W and C bosons and W minus C bosons. In order to have gravity, there's a particle called graviton, but it is not detected yet, right? It is not detected yet. These particles are proved experimentally, but that graviton is not detected. Right? Then we have to know about the strength of each of these forces. If you think about electromagnetic force, and let's say strong nuclear force, if it is strength is 1, electromagnetic force strength is 1 over 100, 1/100th of that. Then weak nuclear force is 1 over 10 to the power 4, 10,000th of 1. Then gravity is 10 to the power minus 39. So you can see this is really weak, right? Compared to this gravity force is really weak. Strongest one is strong nuclear force, because to keep the atom together, the nucleus together, you need like really large forces, right? So it is really strong. It is 1. Electromagnetic force is 1/100th of that amount. This is 10,000th of that amount. This is 10 to the power 39 amount. So you can understand that gravity is really weak. So that's why those gravitons cannot be detected actually. Okay. Then we have something called range. Range. You know that electromagnetic, when you are learning about electric forces, you know those lines expressed to the infinity, right? So the range that electromagnetic force acts is infinite, right? So at the infinity as well, there's an effect from a charge. But for strong nuclear force, even though they are really strong, they are limited to the nucleus of the atom. So the range is around 10 to the power minus 15 or 16. Weak nuclear force also 10 to the power minus 15 range, right? Meters, this is meters. So you can understand these are limited to the nucleus. The gravity, Gravity also, it has a range, infinite range. Range is infinite. Then write down balancing equations, a topic, subtopic, balancing equations. So these are not, these are somewhat similar to chemistry equations, right? You get, but these reactions occur in like under high energy core situations, right? Inside the atom, nucleus, something like that. Write down the first one. So when there's a radioactive decay, neutrons inside the atom can convert it into a proton. These are nuclear reactions, right? Neutron can be converted into a proton. Okay? Neutron can be converted into a proton. So, you know, for chemical reaction, the charges at the both sides should be equal, right? Charges at both sides should be equal in a chemical reaction. So, neutron has a charge is 0. Proton charge is +1. In order to balance this, you can understand that we need an electron here. Now the charge is balanced, right? Understand? Charge at the both sides is balanced. Got it? Then we have something called Lepton number. For these reactions, the Lepton number also should be the same at both sides. So, you remember those 6 leptons? If it is one of those leptons, lepton number is 1, right? If it is an anti-lepton, then the lepton number is -1. If it is not a lepton, it is a 0. Understand? That is how you find the lepton number. It can be either 1, -1, or 0. If it is a lepton, you put a +1. If it is a anti-lepton, anti means antimatter lepton, you put a -1. If it is a not a lepton, we put it a 0. So this is to identify what type of lepton is it. Is it a matter lepton, antimatter lepton, or not a lepton? So is neutron a lepton? Neutron is not one of them in the table, right? So lepton number is 0 for the neutron. Proton is not also a lepton. Proton is not a lepton, right? It is not in the table. What about electron? It is a matter lepton, right? So we put a +1 here. So you can see the lepton number is not balanced. Lepton number is not balanced. So what do we have to do? We need to balance this lepton number. In order to balance that, we have to put something which does not have a charge, because charge is also already balanced, right? You cannot put a charge particle here. So what are the only particles that are neutral? Neutrinos are neutral, right? Remember? So we can put a neutrino here. You can put a neutrino. It could be electron neutrino, mu neutrino, tau neutrino, it doesn't matter. Just put a neutrino here. But it cannot be a matter neutrino, it has to be an antimatter neutrino. So antineutrino. So this is an anti-lepton. So what should be the lepton number? It should be -1. Now the lepton number also is balanced at both sides. Got it? Then another number called baryon number. This is to identify baryons. We know neutron is a baryon, so you put 1. If it is an antibaryon, if it is an antineutrino, we put, sorry, not neutrino, antineutron, right? We put a -1, same here. If it is a baryon, we put +1. If it is an antibaryon, we put -1. If it is not a baryon, we put 0. That's what we do. So neutron is a baryon, right? So we put 1. Proton is also a baryon. So again we put 1. Proton also is a baryon. We put 1. Electron is a lepton, not a baryon, right? So we put 0. Neutrino is not a baryon, right? So we put 0. Understand? So additional to the electric charge, there are 2 cases we need to balance. One is called lepton number, other one is called baryon number. So this is just to identify whether it's a lepton or not, right? If it is a lepton, you put +1, anti-lepton -1. Not a lepton, you put 0.